This is a two-part problem that deals with the topic of impulse. So let's start by getting our information organized. We're given the mass of a tennis ball. We are told that the ball is hit when it is instantaneously at rest, at the top of its trajectory when it's been thrown up. So initially for a collision, it is at rest. That means velocity initial is 0. After the collision between the ball and the racket, we want the ball to be going at 40 meters per second. So that's my velocity final. And what I'm looking to calculate in the first part of this problem is the impulse, or the change in momentum. Pause the video now and think about which equation from this unit we should use. I hope you picked this one. It's our definition for momentum. And if we want to calculate the change in momentum, which is the same thing as impulse, I'm going to take the final momentum minus the initial momentum. Substitute in my given values, put it all into my calculator, and there you have it. That's my answer for the impulse. All right, second part of this problem, we are given some more information. We are given the time of contact. Now we are asked to calculate what the average force is on the ball. Pause the video and think about which equation you would use. I hope you picked this one. It relates the impulse, or the change in momentum, along with the time, to the force of the collision. Okay, so we're ready to substitute in. I actually calculated the impulse in the first part of this problem. And you'll see here in a moment, I forgot a sig fig on that problem. That should be 2.40 kilogram meter per second. Sub in the time, and I get my answer, which is 480 newtons, where that 0 is significant. And there I am, putting that 0 back in, so I have 3 sig figs in both answers.